This video is going to cover section 7.3, describing reactions in aqueous solutions. So there are types of equations for reactions in aqueous solutions. We're going to learn to write a net ionic equation, but that has to happen in steps. So the first thing that we have to be able to do is to write a complete molecular equation. This is going to show the complete formulas of all the reactants and products, and it does not give a very clear picture of what's actually occurring in the solution, but we're going to get down to that when we do the net ionic equations. So if you'll notice here, this is a common reaction that we've been dealing with since we've talked about precipitation reactions. The potassium chromate and the barium nitrate, which are both aqueous, being put together in solution, and we get a solid barium chromate and we get aqueous potassium nitrate. And notice this, just like the homework that you did yesterday, is balanced, so it's 1, 1, 1, 2, and we made sure that our charges were balanced within the reaction, so 1 potassium's plus 1, nitrates minus 1, 1-to-1 ratio, and things like that. So that's the first step, is making sure that we have a complete molecular equation. The next thing is to write a complete ionic equation. All the strong electrolytes are going to be broken up into ions because they're actually dissociated. So if you notice that the potassium chromate, it's aqueous, so we're going to write it as potassium and chromate in ionic form. Notice that this 2 with the potassium comes from right here. Let's get a pen on there. So this 2 right here this is from here. There's only one chromate, so there's only one chromate here with a -2 charge. Barium, there's one barium with a +2 charge. And there are 2 nitrates, so that 2 comes out here. So this 2 here is right here, showing us we have 2 nitrates for every 1 barium. With the -1 charge, notice it says aqueous, 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 aqueous. And on the other side of the equation, what we're going to do is, if it's aqueous, we're going to break it up into its ions, because that's really what's going on in the solution. It's broken up into ions, but we're not going to break up the one that's a solid. So the barium chromate's a solid. We're going to leave it like that. And we're going to go ahead and break up our potassium and our nitrate. And the reason we have a 2 in front of the potassium and a 2 in front of the nitrate is because when it was a balanced reaction, there was a 2 in front of the potassium nitrate. So 2 potassium and 2 nitrate. Then what we're going to do is get rid of what we call spectator ions. Spectators in a basketball game or a volleyball game are not really involved in the game itself. They go in as a spectator, come out as a spectator. The action, what's really going on the court, is happening with the players. So we're going to look at our complete ionic equation and find out what we have that's a spectator ion, and once we've identified the spectator ions, we can eliminate them from the reaction. We can do that. Let's back up a few slides, and we can look at that from here. So we have our complete ionic equation, and in that complete ionic equation, we have spectators. So if you notice, potassium and potassium, both ions, we start off with the potassium ion in this reactant side, and we end up with the potassium ion in this product side. Chromate, however, let's get a different marker for that. Chromate is actually one of the players because it is bound up with barium in this solid. So here's our other player, barium, and it's combined in the product. And then we go back to nitrate and look at nitrate. 2 NO3s here, there's 2 NO3s here. So potassium and nitrate are both of our spectators in this case. And in order to get to the complete ionic equation, we're going to eliminate the spectators and just end up with what's actually going on, the players who are on the court playing the game. So for a net ionic equation, we're only going to include the compounds that undergo the change, or the players in the game, and this is what we eliminated, everything but this, and this is our net ionic equation with no spectators. So let's take a look at a concept check that's going to help us through doing one of these entire problems when you're asked to do them. So it says to write the molecular equation, the complete ionic, and the net ionic for this reaction. So we have cobalt 2 chloride and sodium hydroxide. I'll go ahead and show you what the molecular equation would look like and just add a few comments in here. So cobalt 2 chloride, remember that means that's 2 is the charge on cobalt, so it takes 2 chlorine. That's where the 2 here is on chlorine, and it's aqueous. We have the 2 sodium hydroxide, and I'll talk to you about balancing in just a minute, but the sodium hydroxide, sodium is a +1, hydroxide is a -1. It is also aqueous because that's part of the reaction. So we do the double date switch. We have the positive cobalt and the positive sodium, and we have the negative chloride ion and the negative hydroxide ion. So when we put those together, what we're going to do is a double date switch. So we're going to put the positive cobalt with the negative hydroxide. Cobalt had a +2 charge. Hydroxide has a -2 charge, so it takes 2 hydroxides. That's where we have that there in order to balance that out. The sodium chloride is a 1-to-1. Sodium is +1, chlorine is -1, so we have NaCl. And the next thing you need to do is make sure that with a molecular equation that you balance it. So we go through and we balance the molecular equation. We put a 2 in front of the sodium hydroxide and a 2 in front of the sodium chloride. Now our chlorines are 2 here, 1 cobalt, 2 sodium, 2 hydroxides, 2 hydroxides, 2 sodium. This part might take you a little bit longer just because you have to slow down and do it. So we're just kind of skipping through it because I know it's something you can do, even though it may take a little bit of time. The next thing we need to do is to look and to determine if these products are solid or aqueous. And you'll notice here that they've identified this as a solid and sodium chloride is aqueous. So those would come from going to your solubility rules. And if you look through them, you'll notice that on rule number, rule number 5, most hydroxide compounds are only slightly soluble, and this is not one of the exceptions. So that means slightly soluble is going to be solid here. And sodium chloride, of course, is a sodium salt and a chlorine salt, chloride salt, so it's very aqueous, so it will ionize in water. So that's our first step, is the molecular equation. The next step is to write out the complete ionic equation. And I'm going to do that for you now. And what we're going to do is we're going to split apart anything that's aqueous. So this is aqueous. We're going to split it into its ions. We have cobalt +2, and it's aqueous, plus 2 chlorine, so 2 Cl-, and it's aqueous. Notice how we're putting the charges up here. We have this 2 in for the sodium hydroxide, so 2 sodium. We're going to split it into ions, and that's aqueous. Plus, that 2 also goes with the hydroxide, so we're going to do 2 hydroxides, and that's aqueous. And on the other side, we're going to break up only the one that's aqueous. We leave the solid together. So we're going to come down here and write this. So it's going to be COOH, 2 solid, plus 2 sodium that are aqueous, and 2 chlorine that are aqueous as well. When you get to this point, if you balanced your equation correctly, your spectator ions are going to cancel without any issue at all. So we got to go through and find out what our spectators are. Let's find out who the players are. So I need to know, here's my player with cobalt 2 hydroxide. So I need to go back and find my cobalt, and I need to find my hydroxide, because that's what goes together to make the cobalt 2 hydroxide. The other ones should end up being spectators. So we have 2 chloride ions here and 2 here, so we can cancel those. We have 2 sodium and 2 sodium. We get rid of those. And now that we've looked at our complete ionic equation, we need to go ahead and look at our net ionic equation. So net is what happens when I get rid of my spectators. So I'm going to go back and take this off here and show you their rendition of it. Here's your complete ionic equation. And then you get down to your net ionic equation, which is going to be the cobalt +2 aqueous plus 2 hydroxide aqueous. But when you put them together, they're going to form cobalt 2 hydroxide solid. And that's all there really is behind a net ionic equation. It's just really important that you remember that you write out the molecular, then you take the molecular, make sure it's balanced, and you find your solubility rules and decide what your product should be. And of course, if these were both aqueous, you would stop there. You would write no reaction, and you would stop right here. You wouldn't go on because there would be no reaction. But with there being a solid formed, break it up into ions, get rid of your spectators, and get to your net ionic equation. Best way to do it, again, like all the other problems, is just to practice.